So, so take a look at problem 34 on the homework that I sent before. Do you guys have this?
Mm-hmm.
So let's start by drawing a diagram. So this problem, uh, so you have a semicircle. I've drawn the whole circle. Um, and so let's draw. So there's semicircle AB and center O. Um, let's see. And then there's a point P that's on the diameter. And then let's see. So you should draw this carefully. So there's P on the diameter, and then there's D and E. So I'm going to skip the first two conditions and look at DP is perpendicular to AB. So that's what will help me draw D. So it tells me D is on the intersection of the circle with the perpendicular from P. So let's draw that. It looks something like this. And here is D. And please interrupt me if there's anything that's unclear or you'd like me to explain some more. Um, Now we have E so that there are some angle conditions. So what are the angle conditions? They are that angle PDO equals angle EDO. So maybe we can draw like this. Where these angles are equal. Um, okay. And then DEO is equal to OEB. So, okay, so is the diagram clear to everyone? Does it make sense?
Yep.
Yeah, please let me know with maybe like a thumbs up or you can say. Kareem, is the diagram clear and does it make sense what we've done?
Yes.
Okay, it's so um, yeah, okay, so maybe I'll give you 5 minutes to think about the problem, and then we'll talk about maybe how we can solve it. Yeah, and if you figure it out, please let me know that you figured it out. And if you find any observations or anything, please say those as well. Okay, let's reconvene. Um, so did you guys come up with any ideas? Even if they're small ideas, that's okay. Maybe some ideas of how you can uh, approach the problem, like strategies for how you can solve it.
Maybe use the fact that the lines DO and OE are equal.
Mm-hmm.
So we have an equilateral, isosceles triangle, which
Okay,
means two angles must be equal.
great. So we have an isosceles triangle, which means two of these angles are equal. So it's hard to mark this, but let's try to. So we'll just say like this. So because we have an isosceles triangle, actually these angles are all equal. Okay, I mean that's a little hard to understand. Maybe let's.
Also, OB is a radius, so we have OE equals OB.
Oh, great. So this is also so looks like Karam is joining us. Hello, Karam. So you mentioned you had some difficulty with this problem. So this is the one we're going over. Hello, Karam. Can you hear us? Karam, are you able to hear us? Karam, do you understand the problem that we're going over? So this is the problem that you mentioned that you tried to solve but you could not. Okay. Um, yeah. So far we've made some observations that there's three radiuses that are equal. So there are actually five angles on this picture that are the same. Um, okay, so that's a good observation. There are these five equal angles. So what can we do from there? What is our next step?
Maybe get an equation for the angle DOP.
Okay.
So substituting the angles as x and then solving for a straight line summing up to 180
Okay, great.
or something.
So which one do you want to call x?
Um, Maybe one of the like any of the equal ones or something.
Let's call these
Yeah,
angles
sure.
the x.
Okay.
And then what is DOP?
90 minus x.
90 minus x. Okay. And now your idea is to solve for this one being this is it this here is 180, so you want to solve for that one.
Yeah.
Okay, good. So, so how can we do this? Maybe space. So, right, angle P O B is equal to. So we should split into three angles, right? So we can get P O D, uh, P O E, and E O B. So right. Um, and then I guess yeah, we can write each of these. So the first one should be is 19 minus x, what we're looking for. And then what about the other two? So actually, in this case, the other two should be the same, even though it does not look like that. So my picture is um, drawn improperly. But maybe we can see that the other two should be 180 minus 2x. Is that clear? Um, is it clear how this goes? So this should be 180. So that gives us x equals is that right? Maybe that's right. G4. Okay. Then we can finish the problem from there. Yeah, does it make sense? So is it clear? Actually, does it make sense? Okay. Kareem and Karam, does it make sense? Maybe you can use the thumbs up. Is- Okay, yeah, I have it. Okay, so next, I want to go over some problems that are not on the list that I sent you. So I will now send you in the chat. I will send you. Oh, so what I will do is I will in the WhatsApp I will send a list of problems. So I just sent to the WhatsApp a list of problems. So let me know once you open it. So okay, can you hear me now? Is it clear? Can you hear me now? Karam, is the volume lower? Is the volume better now?
Yeah, it's clear now.
Okay. Um, so I just sent a list of problems to the WhatsApp. So let me know once you've opened it.
Mm.
Okay, so have you been have you were you able to open the document? So this is problem 18 on the one I just sent. So Karam and Kareem, were you able to open the document?
Yes, I'm able to do it.
Okay. And Kareem, do you know which problem I'm working on? Do you see the problem?
Mhm.
Yes.
Great. Okay, so this is problem 18 um, from this thing. So there are 2 points. So there's A, P.
Mhm.
So there's A, P, and B. Um, and the condition on A, P, and B is that so this line and this line are equal. And what else? So then there's a C here. No, that isn't C. Uh, there's a C here. So C is on the circle, and D is like this. No, no, that is not. So D is like this. Oh, sorry, this is M. Okay, there's M. Okay, there's M, and the point is to show this one. AM.
Karam, can you please turn off the mic?
I think maybe your mic is a little bit distracting. Is it okay if we turn it off? Great. Just unmute yourself if you have any questions you can to ask. Okay, so any ideas where we can start with this problem? Or any observations or anything where to start? Or if you think it's difficult, maybe why is it difficult? So what I'll point out is that for me, the most difficult thing about this problem is this condition. Like this thing that we're trying to prove is a kind of a very unnatural um, thing to me. It's not like prove some angles are equal or prove something is a square or something is a parallelogram. It's this prove that these two lengths that don't really look related add up to each other, right? So what you need to do to solve this problem is you need to somehow to do something clever that allows you to reinterpret this condition. So any ideas how you can, change the problem by maybe adding some point or something that will make the condition easier? Does it make sense what I'm asking?
Yes.
There's one very clever thing you can do that will make this problem much easier to work
Maybe we can extend BC.
with. Okay. So we
Yeah, so that the new segment is as tall as so that let there be a point up there. We've already used that. Oh, okay. So that B prime is equal to AB.
great. Yeah. So the idea is you want to somehow. Okay. So we can make it so bm prime is equal to. Did you say ab, or maybe you can? Did I understand your
Uh,
idea correctly?
I'm not sure. We can. I'm not sure which one to try. So
Okay. But
if
maybe.
I were to solve this, I try both ways.
So what is your idea? So it's to make you want to make you want to make it so m prime. So you want m prime on BC, and then did I put it on the correct side?
Yes.
Okay. And then what equality do you want?
Um, I'm not sure. The one you just made could work.
Good. So this one, okay, m prime c. So if you have this one, yeah. So at least now it's easier what we're trying to show, right? Um, Now we're trying to show that two segments are equal. Um, but still, it's hard for me to relate these segments. Um, yeah, I mean, you can maybe draw something like this, right? You can draw something like this. Um, yeah, but yeah, okay. So it could work, but I don't see any way forward. Um, I don't know how to take advantage of this condition that AP equals PB. You know, yeah. So I don't know. Maybe it could work, maybe not. Any other ideas? But what we should do, we should definitely, extend something or add a point, something like that, so that it becomes easier. Here's maybe something that can change our point of view. Let's instead think AB minus MC equals BC. So if you write it like this, what is the sorry, did I write the correct one? Sorry. Something I've written wrong. That's pretty bad. I meant to write M. Sorry. But yeah, hopefully it's AM is what we want, right? Not AB. Yeah. So if you write it like this, that maybe now there's a good suggestion for a point, right? What should we do now? Any ideas? So what we can do is we can take this MC, right? And so what if we introduce a point here? Maybe called C prime. And the idea is we make it so MC equals MC prime. Yeah? Does it make sense what this new point is?
Yes.
So now if we have this new point, now what is the thing that we want to show? So you want AM minus MC is BC. But now we put a new point, C prime, which MC and MC prime are equal. So what are we trying to show now?
That AC prime equals BC.
Good, yeah, so that's the new idea, right? So we want AC prime and BC, these guys. Okay, so let's maybe draw. Okay, any ideas how this one, how we can show this one? This is actually much easier to show. Well, maybe we need some extra lines. So maybe any ideas? We need in order to compare AC prime and BC, we need to draw some extra lines. Yeah, maybe we can do something like this. First we draw this. Okay. So now this AC prime is on a triangle, APC prime. And we can draw this one. Okay. So there are now these two triangles that we are trying to compare. Does it make sense why I added these segments?
Which triangles are we comparing now?
Right. So that's a good question. So we want to show AC prime and BC are equal, right? So which triangles can we compare?
Maybe mm, maybe BCP and C prime PC or something. I'm not sure.
So one of them was BCP and the other one was what?
BCP and C prime PC.
So if you have C prime PC and BCP, right? So okay, BCP, C prime PC. Wait, so let's see which angles would have to be equal. So this is where it helps to have a good picture. Um, in the picture, do they look equal? Yeah. So if you ever make a conjecture like this, the best thing to do is draw a good picture with with a compass and a straight edge and see if it's true. Um, so what I'll tell you actually is that I don't know how easy it is to tell from this picture, but they're actually not equal. The but maybe there's a reason you can tell. So this C prime PC is actually a very special triangle. What property does this C prime PC have?
It's isosceles.
That's right. So C prime PC is isosceles. Does that make sense? That it's because what's happening? We have this right angle here, and then we reflected C over M to get C prime, right? So these angles here are equal. Does that make sense? So this is really an isosceles triangle. Um, so if it were to be equal to BCP, it would have to be something kind of miraculous, right? Because you would need basically this angle here. Maybe you cannot see it. You would need this angle and this angle to be equal, right? But for that angle to be equal, this C really needs to lie halfway between P and B on the arc. Does that make sense? And remember the way, yeah, and I think C was actually just chosen arbitrarily, right? So A, P, and B are equally spaced, but C is kind of arbitrary. So um, it actually should not be that they're equal. But I'm glad that you mentioned these triangles because it's very important to observe that this C prime PC is isosceles, right? So it's a very important observation, right? That this is isosceles. Okay, so that's going to be very useful for us. But now let's return to the original thing. How will we compare AC prime BC? What triangles will we use?
What about BMC? Because it's also isosceles.
BMC. So BMC is my understanding. Yeah, BMC might not be isosceles, right? Because MC prime and CB, or sorry, MC and CB, right? So if so, we wrote BMC, maybe like space. So you were suggesting BMC, right? So with BMC, in general, MC and CB may not be the same.
Oh, I thought they're equal. Okay.
No, so in the problem, right? So that they're not. So that was maybe, yeah, maybe it's not clear. There's 2 ticks and 3 ticks.
Oh yeah.
So they're not equal in general. But actually, there's 2 triangles that are drawn already in the picture. You don't need to add any segments that will compare AC prime and BC. Hmm. Okay, maybe it will help us if we can find some equal angles, right? So we already have, so already we have this angle and this angle are equal from the isosceles triangle. Are there any other equal angles in this picture?
Maybe you could use the fact that ABCP is a cyclic quadrilateral.
Right. Okay. So ABCP is cyclic, so we get some angle equality. So which one can we use?
Let's see. Maybe CBP equals PAC.
CBP. Can you guys see this color? Is it okay? Maybe I can choose it. Yeah. Yeah. So CBP and PAC are equal, right? Good. So now let's think. Maybe is it clear which triangles we want to use? You know, CBP and PAC are equal, and we want to compare AC prime and BC.
APC and BCP. Or no.
Yeah, so let's write BCP because BCP is the only triangle that has B in it.
Oh yeah. BCP and I think AC prime P.
So let's think about these. BCP and AC prime P, right? Good. So yeah, so they have, okay, so they have BC and AC prime in the correct slot. So if BC prime and AC prime are equal, then it will show that BC and AC prime are equal. And they already have an angle in common. So any ideas how we can prove this? So we already have one angle. Is there a side? Is there a side we can match?
Yeah, C prime P and PC.
Great. So we already have C prime P and PC. So we have, how can I? Yes. So we already have. So we already have. Um, C. So we already have C prime P and PC, and we already have one angle, right? So we're very close. Um, is there anything else? So so maybe there's a condition in the problem we forgot about. That will help us. Yeah, so if you read the problem statement, actually there's
Oh yeah, we have AP equals PB.
right, yeah. So remember, A, P, and B are equally spaced on the circle. So we have right, so we have AP equals PB. Yeah. So is that enough for us?
I think so. Yeah.
Um, yeah, so we have two sides and we have an angle. Um, so it should be enough. There's one thing we need to worry about. So maybe yeah, okay, so we actually should be done, but there's one thing you should worry about. So what did we show? We showed two sides are the same and then there's an angle. But this is this condition we sometimes call it um, SSA similarity. Do you guys know this? There's like there's SAS, SAA or something, AAA. So we have two sides equal and then we have an angle. So it's something like this. Maybe we can just maybe. So if you have this situation, you're almost done, but there's a problem, which is like this. Um, here's so here's your angle. Here's your side, and then you can have either like this or like this. There's actually two triangles that have this. Do you guys understand the picture that I've drawn?
Yes.
So you need to actually decide whether this angle is acute or obtuse. Okay. So does it make sense? So if I have SSA, so this is SSA, you cannot immediately conclude that the two triangles are congruent, you need to make an argument about whether the remaining angle is acute or obtuse. So that's actually exactly the situation here. Um, so yeah, you need to make an argument whether the angle is acute or obtuse. Right. So what is that's one of the angles. So it's those two angles we need to compare. We need to make sure that they're both obtuse. Otherwise, it doesn't work. Um, any ideas how to do that? It's actually not that difficult in this case.
For ACP, we have since C prime PC is okay. Sorry, for AC prime P, we have C prime PC is equilateral, so PC prime C is less than 90 degrees.
Yeah, good. Yeah, so yeah, that's right. So we have an isosceles triangle that will tell us that yeah, the leg angles are one of them is acute, so AC prime P is obtuse. Does it make sense? So okay, so that one is obtuse, and then what about BCP? So actually, it's almost the same argument. So what's the idea? So BCP being obtuse is actually the same as um, so it's the same as PAB being acute because those are complementary. Um, and PAB is the same as PCA because they have the same arc. Does that make sense? I'm saying PAB and PCA, they're the same. The angles have the same arc because P is the midpoint of AB. Does it make sense?
Which angles again?
So it's the ones I've written. The ones I've written here: PAB and PCA. Does it make sense?
Yeah, but how can we prove that they have the same arc? Because we only know that AP is equal to PB.
Ah, okay, right. So what is the situation here? So um, sorry, I don't know. Sorry, it's a very cluttered picture. Find some space. So okay, maybe I can write. This is what we understand. PAB and PCA are the same, right? And the point is, so PAB is half of, so yeah, if you go, maybe it's, so PAB is half of the arc PB. Does that make sense? And PCA is PCA is half of the arc PA. But now if we say AP and PB are the same, that means the arcs are also the same. Does it make sense? Okay, good. So now, yeah, so what was the point of all that? Well, if PAB and PCA are the same, well, this guy good. So, right, so PCB is 180 minus PAB, and PCA is sorry, what did I write? Sorry, I meant okay, good. Okay, so does it make sense? The point was to compare the dark green angles. Okay, so does it make sense? The point was to show that both of the dark green angles are obtuse, and this argument, and in fact, actually, this shows that they're equal. Does it make sense?
Yes.
So Okay, great. So yeah, so thanks for the comment, Karam. Um, so is your argument the same as what we've discussed now, or? Okay, so any questions or any comments on this problem? So this one is difficult because there's a couple of steps you need to do. First, you need to realize how to interpret this sum of lengths condition. Okay. And even then, once you interpret that, it's still hard to show, AC prime is BC. I see. Okay, great. So okay, maybe let's go to the last problem that I wanted to talk about. We have time at the end, Karam. We can discuss your argument for this one. So this one is so this is problem 21 on the new document. So have you guys found the problem?
Uh,
Let me know let me know once you found the problem. So did you guys find the problem on the list?
yes.
Abdullah and Karam, have you guys found the problem? It's problem 21 on the new document. Okay. Okay, good. Yeah, hopefully Karam can rejoin, but let's start the discussion. So any idea? So like let's first read the problem. So we have a triangle. Um, so O is the circumcenter of the triangle, and then we have another circle. So this circle it goes through B, O, and C. Okay, so it goes through B and C and the circumcenter of the original triangle. And so this circumcircle omega, it intersects AB and AC at P and Q. Okay, so that's good. So there's A, B, C, and then there's O, and then there's P and Q. And the last point is there's N, and N is a diameter of the circle omega. And what is our goal? So our goal so our goal is that APNQ is a parallelogram. So let's write that. So we want APNQ as a parallelogram. So I guess, okay, so first thing I'll mark something. So whenever you have a diameter, you should immediately mark the right angles. Yeah. So anytime you have a diameter of a circle, that tells you that these angles are right angles, and that should always be part of your picture. Yeah, okay, and what else is there? I guess there's a lot of these cyclic quadrilaterals. There's like P, B, O, Q, C. Um, yeah, okay, so that actually gives us a lot of angles as well. Great, so any ideas how to proceed? So let's just, maybe I'll mark what we're trying to prove. So we're trying to show that APNQ is a parallelogram, which means we're trying to show this parallel. And we're also trying to show this parallel. Yeah, so AQ and PN should be parallel, and AP and QC. But maybe I'll write a question mark because we don't know. Okay. Okay, so does it make sense? All of the observations we've made. Okay, so any ideas how we can proceed? How do we show that something is a parallelogram?
Maybe you can make an alternate angle or something.
Yeah,
Show
so
it's theoretical.
great. So by alternate angle, do you mean something like that?
Yeah, exactly. Or up there. The corresponding, yeah, it was.
Like that maybe?
Yeah.
Okay. Yeah, so usually you want to show some kind of angle equality, right? Good. So we can try to introduce some kind of um, some line so we get some alternating angles. There's also another way to show something as a parallelogram. It's similar. Um, Actually, you can just show that opposite angles are equal. Is that right? Yeah. So let's just have a little review. So maybe I'll draw. if you're ever in this situation, it actually for free gives you that it's a parallelogram. So there's many things. So do people understand this argument? If these are equal, then you get a parallelogram. I mean, it's because if those are equal, then you actually get um, this, right? And then you have alternate angles. Um, so the reason I brought this one up is because then you don't have to add any maybe extra lines to this picture. You can already see those angles here, right? So any ideas how we can proceed? Hmm. Let's see. So hmm, maybe hmm, actually maybe let's do this. So let's look at these angles. So those are supposed to be equal. Um, so one thing I like to do is when there's a triangle already, we can mark some angles. So let's say this is A. Mm, I've actually forgotten how to solve this problem. So what can we do? Hmm. Does anyone have any ideas? Let's try them. So want. So let's just write what we want. So what we want is so does it make sense what I wrote below here? So if we can show that AQN and APN are both 180 minus A, then we will be done, right? Does that make sense?
Yes.
Right. So what is it that we're trying to do? We're trying to calculate two angles in this picture, right? So there's this angle here, and we want what? We want that it's 90 minus A. And 90 minus A. So these are the two angles we want. And we want them to both be 90 minus A. Okay. Does that make sense?
Yes.
And now actually, yeah, so now I remember this one. So actually from here, you can actually find these angles from the picture. Yes, maybe I'll give you a moment to think. But the point is, these angles are very good angles because they're related to arcs on the circle, and you can find these arcs. Okay, so maybe yeah, you can think for a moment. You can actually calculate these angles exactly because they're related to arcs on the circle. I mean, another way of saying this is that you can relate these angles to angles that actually just have to do with A, B, and C, that have nothing to do with like this new circle. Right, so you can use this big cyclic quadrilateral PBOQC. You can use the cyclic quadrilateral to relate these angles to angles that actually come from the original triangle. So maybe let me explain what I mean. Um, so, I drew in these two line segments, and the point of this was that now these angles we care about, right? So one of them, right? So one of them becomes this. So that one we want to show is 90 minus A. That will take care of APO. Does that make sense? Okay, so yeah, so I'm using that angle to calculate this angle. Does it make sense?
How did we get the 90 minus A?
So the 90 minus A is maybe it's a question, right? So it's what we want.
Oh no, I mean on OCB.
So that's also I'm saying I don't know that it's true, but I'm saying it's equivalent to what we want.
Oh yeah, I mean how did we relate it to the
So
yeah.
the way we're relating it is using the cyclic quadrilateral PBOC.
Okay, I see.
Yeah, good. And then we have this other one. Is now we want AQO as well, right? So that's the other one we want. So that's also related by a cyclic quadrilateral to something that that is easier to understand. It's related to it's related. This one is related to that one. Okay, and that's through the cyclic quadrilateral POQC. Sorry, no, BOQC. Okay, so you have BOQC, then it tells you that the two opposite angles are complementary, so actually the two marked angles are equal. Does that make sense?
Yeah, I get it.
So now actually our job is easier, because what is our job now? We just need to show um, this is our new job, to show these two angles are 90 minus A. Does it make sense what and this is much easier because now there's just like I mean we have a triangle and we have its circumcenter. It's a lot easier to work with. So what I'm going to do is I'm going to open maybe a new page, but maybe you can draw on your own. But um, So does it make sense? This is the original problem is actually equivalent to this problem. Yeah, does it make sense? It's really the same. Should I go back
Yeah.
to the previous diagram, or is it? Great. So, and this actually, okay, is you should think about this picture. You should know all the angles in this picture. If I draw a triangle and I draw its center, you should actually, I mean, this is an exercise you should do on your own, but you should know all the angles, but we can do it here. What's the idea? The idea is, um, well, first of all, uh, since we have this circle, we can use the circle, right? So uh, CAB, that's our angle A, is actually 1/2 of COB, right? Because COB is the angle of the arc, and CAB is half of the arc, right? So this guy is 2A, and then we have an isosceles triangle. Okay, so the other two are 90 minus. Does it make sense?
Right, yes.
Yeah. Good. So yeah, so I mean this picture you should know well, you should know all the angles in this picture. Okay. But yeah, so that's much simpler than what we had before. Yeah, so that solves the problem. So go back here. Great. Um, Good. So any questions about we did maybe 3 problems today. So any questions or any remarks? So the level of these problems, was it good? Like was it helpful for you guys? Like too hard, too easy?
They're good.
Um, yeah, so what I'll do is I will send a homework, maybe in a couple hours, maybe not immediately. I will send a homework, and the homework will have some problems of this difficulty, maybe a little bit harder, but of this difficulty. And what I want you to do is I want you to solve, well, solve as many as you can, but write a solution to at least one of them, okay? And send them to me. I think it's good if you guys, especially Abdullah and Kareem, since you guys will be going and competing soon, I think it's good that you at least write occasionally some solutions. Does that sound good?
Yes.
Yeah. Okay, so yeah, so I'll send the homework. If not tonight, then by tomorrow morning. And the homework will also have some pre-session problems for Wednesday. So Wednesday I'll cover some number theory topics. So I'll add some pre-session problems for that. Those will be easier, but still, take a look at those if you can. There will be some challenging ones out there as well. Good. Okay, so I will